Hello, welcome to today's class. Today we have a very nice exponential equation before us here. The question reads x plus 1 all to the power of 4 plus bracket open s plus 2 close bracket all to the power of 4 equal to 17. What is the value of x? If you look at this question carefully, we have to solve for 4 values of x. So we have to get 4 root to this challenge here. So how do we get the 4 root? So we take our solution here. Solution. All right, so from this question, the first thing we're going to do here is this. We can use binomial expansion to open this. We can equally use binomial expansion to open this. So if you are familiar with Pascal diagram or triangle, we can open this easily. So using binomial expansion, okay, we have to use binomial expansion, right? Okay, so the first expression, which is this, we give us here bracket open x to the power of 4 there plus 4x to the power of 3 plus 6x squared plus 4x plus 1 close bracket. So the whole of this is for this, right? Okay, so we do same thing for this. So we have here plus, let's continue on this side of it because of space. So bracket, again, we are using binomial expansion to open this. So this will give us x to the power of 4 plus 8x to the power of 3 plus 24x squared plus 32x plus 16 close bracket. Everything equal to 17. So if we add up everything, what will this give us? So this now implies here we are having s to the power of 4, s to the power of 4. So this will give us 2x to the power of 4, okay, plus this we're having 4x to the power of 3 plus 8x to the power of 3, and that will give us 12x to the power of 3 there plus here we have 6x squared plus 24x squared, that gives us 30x squared there plus 4x plus 32x will give us 36x plus 1 plus 16 will give us 17, everything equal to 17. So if we bring this 17 this way, this leaves the system, that gives us 0. So we are now left with 2x to the power of 4 plus 12x to the power of 3 plus 30x to the power of 2 plus 36x, everything equal to 0. Easy. Good. So if you look carefully, you discover that 2 is common. So let's divide through by 2. So if we divide through by 2, end up having s to the power of 4 plus 6x to the power of 3 plus 15x to the power of 2 plus 18x equal to 0. Again, you discover x is common or true. So we are not to divide by x. Why? Because if we divide through by x, then we are going to come out with only 3 solutions. But recall we said we are coming out with 4 roots according to the highest power here. So what we do here now, we factor out x from this expression. So if we factor out x, this will now give us x into this, we give us s to the power of 3 plus 6x squared plus 15x plus 18 close bracket equal to 0. Here we are now having this times this. So we can equate this to 0, equate this to 0. So automatically we're going to have here from case 1, x is equal to 0. This is the first root to our question here, our nice algebraic equation, our exponential equation. Now if you substitute x equal to 0 into this system here, it will give you 17. I've done that already. Now let's go ahead and take our case 2. So case 2, so the question is x to the power of 3 plus 6x squared plus 15x plus 18 equal to 0. This is a third order polynomial equation. So how do we get the first root to this polynomial equation? We do what is called the trial by error method. And if you do that carefully, you're going to have x plus 3 as a factor. How did I get this x plus 3? Bring out all the factors of 18, which you have to do with plus minus of the factors of 18, and substitute them into this equation. Everything, if you do that, you discover that x plus 3 will satisfy this equation. So now that we've gotten one of the factor, okay, we say this is a factor of this polynomial. Okay, so what we do, we need to get the other two factors from here. So we use the long division method. We can equally use the synthetic method to get it, but here let's use the long division method that is familiar to us. So what we do here, we now draw up our line, then we put the divisor, which is x plus 3, and we put the divided inside x to the power of 3 plus 6x squared plus 15x plus 18. Let's cover it up well. We use this x to divide this x to the power of 3. This will give us x squared. Use this to times this. This will give us x to the power of 3. Then plus this time this will give us 3x, okay, squared. Then we rule off. We bracket this, and we subtract. This will leave. So minus will come in here. So 6x squared minus 3x squared will give us 3x squared. Again, we use this to divide this. So we are left with plus 3x. So we put it here, plus 3x. If we use it to open up everything, in other words, to multiply everything here, we're going to come up with, before then, let's bring out this plus 15x, please. So we bring out plus 15x. So if we use this to open up this will give us here 3x squared. Then this time this will give us plus 9x. Then again we rule off and we subtract. This will leave. So we're going to have 15x minus 9s. This will give us 6x. Bring the last term, which is plus 18, then. So we use this x to divide this again. This will give us plus 6. Okay, so let's use this to multiply everything here. So this will give us here 6x plus 18. If we rule out here again, then this leaves, so we have 0, 0. So let's bring out the quotient now. So this now implies, or this shows that we're going to have our factor. We have x plus 3, first one. Then the next one, we have the quadratic equation x plus 3x plus 6 bracket equal to 0. Okay, so this implies this. So we now solve this quadratically. So again, let's establish this one. So we know that x plus 3 is a factor now. Okay, so this is a factor. We said this is equal to 0. Therefore, our x equal to minus 3 is our x2. So this is our s2. Okay, now we have our s2. What we do next now, let's go ahead and solve this quadratic equation. Now, if you check this square plus 3x plus 6 equal to 0, if you use the determinant factor, you discover that we're going to have an imaginary root from here. But how do we get the imaginary root? We cannot use the factorization method here. So let's use the quadratic formula. So this now implies that our x will now be equal to a minus b plus minus the square root of b squared minus 4ac, right, all over 2a. All right, so from our formula, we're going to have our x is equal to, again, what is our a from this quadratic equation? We know that our a will be equal to your positive 1, b is equal to positive 3, c is equal to positive 6. So if we substitute, we're going to have this to be minus 3 plus minus the square root of minus 3r squared minus 4 times 1 times 6, right? All over 2 times 1. So this is equal to minus 3 plus minus the square root. Minus 3 square will give us 9 minus 4 times 1 times 6 will give us, to have here, 24, everything all over 2. Good. Are we learning something here? So this will now be equal to minus 3 plus minus the square root. 9 minus 24, that will give us minus 15. Minus 15 all over 2. Now recall, we have been taught that our square root of minus 1 is equal to iota. So we can bring in iota in here. So this will now give us here minus 3 plus the square root of 15 iota all over 2. So we have our x3, s3, and x4 from this. So in all, from the first one, we have our x1. So can I say, therefore, x1 is equal to 0. Then x2 is equal to minus 3. Then x3 is equal to minus 3 plus the square root of 15 iota all over 2. And x4 is equal to minus 3 minus the square root of 15 iota all over 2. So these are the 4 roots to our equation, our exponential equation. So if you substitute all these solutions, all these roots into the original equation, this very equation here, you will discover that they will all satisfy the exponential equation. For the sake of time, I would as well go ahead to substitute all these into the equation and see how they will all satisfy the original equation. Again, if you've not subscribed, do well to subscribe, because at Math Prowess we release math challenges, solution to math problem, and we solve them step by step to the point that even a janitor will understand our steps, our solutions. Okay, thanks for being there. Bye for now.